This projector's in the ceiling. It's in the ceiling, Barbara. You're not going to reach that one. Ah, here comes help. So just chat among yourselves for a second while we do all the AV stuff. Do you want to try here?
Okay, while we're doing that, given this is, did you want to slide it before I slip it around?
Oh, I'll do it at the end. Grant. I'll do it at the end. Let's see if this does anything.
Nope, that's not the problem.
Oh.
Oh. That is the problem?
It's the local machine, yeah. Is he still there?
Let's try one more time on the Chromebook. Just.
Right.
Oh. Okay, so it's over there.
There we go.
It's there. Perfect. Thank you.
Okay.
This is a real problem of having to be at the working group chair's lunch right before your working group session. Okay. Uh-oh. Thank you.
Let me just try this.
Stop it. Okay, Stephen, stop playing with the remote. Welcome, everybody. It's time to have your regular dose of IETF fun at the Homenet. And here's the obligatory first slide with lots of information, which if you haven't figured this out, you're really lost because you are here and you are here at this time on this day. And let's see, we have, who's doing Jabber? Mikhail? And who's doing minutes? Stuart, thank you.
Thank you both.
Okay. Oh, note well. Does anybody not know what this thing says? Okay. So we've got the blue sheets going around. We've identified the note taker, identified the jabber, which means that, real quick, just going to go through where we are on drafts. Simple naming was updated. I think, huh? Oh, does anybody, oh, I'm sorry. Darn it. Okay, so we've got the Ted Lemon show, and we're actually going to try to to hurry the Ted Lemon show up so that we can have more Ted Lemon at the end. And we're going to have a Ted Lemon as sort of the bread in a sandwich, and we're going to put Michael in the middle of the sandwich.
This is Ted Lemon, and I'm feeling deeply alarmed. When we originally set up the agenda, so we've got 15 minutes on the agenda for simple naming. I don't know that it necessarily needs to take 15 minutes. I have a couple of other slides. One of them that I think is actually kind of important to talk about is like marketing. I know that that's a term that most of us here at the IETF consider to be bad, but it's actually going to be a real problem for us if we spend all of this time working on Homenet and then nobody uses it. So we need to figure out how to promote Homenet adoption if we actually want our work to matter. So I'd like to talk about that a bit. I have kind of a medium-length slide deck about it.
Okay, and so that's just going to be in the simple naming, in those
Well, let's
50
see.
minutes or less.
Let's see how the simple naming discussion goes. If the simple naming discussion goes to 50 minutes, we may be hosed, but hopefully not. And,
Okay.
and so the simple naming discussion, by the way, is actually divided into two parts: the simple naming updates and what we need to do with HNCP. So.
Okay, great. And then Michael, you're going to be on tap to do, alrighty then. And then we've just got some chair-led discussion points here about where we at about securing the home network. Do we want to recharter? You know, those standard kind of things that we hopefully won't spend a whole lot of time on. Alrighty, no bashing. That. And so Babel Profile 7 is just hanging out there, and Ted did update to 03, and the other drafts were not updated. And that's all my slides, which means we're going to start with Ted now. Let me see. And we have the magic mouse over here.
That's an Apple product.
Also like full screen.
There you go. Oh, no, what's the
Yeah,
scrolling
I thought
action?
we had it where it like was able to go page to page, and I was looking for the. Oh,
Yeah.
You're so clever.
I'm a frequent Chromos user, so that makes me an expert. Okay, so Homenet naming architecture update. So I'm actually kind of just going to dive right into this. By the way, is there some way to get rid of that stupid mirroring thing? Thank you. So basically, the current update. I'll just give you a little brief overview. The current update is kind of a long attempt to a long overdue attempt to actually put everything in the document that needs to be in the document with a sufficient degree of clarity that we actually know what we're talking about on each point. And I believe that it currently does that. I think this is the first version of the document where there's no real hand-waving going on. That isn't to say that there isn't more work to do, but I think the list of things that need to be done is now fairly complete. And if you haven't read the document and you're interested in the document, this would be a good time to read it and point out on the mailing list whether you think, in fact, the document is complete in terms of its feature set or not. We can if you want. How many people have read the document? Okay, that's almost a majority. This is part of the marketing talk I need to have later. So anyway, what has happened in the document? The first thing is that we actually came up with a solution to how to handle the DNSSEC problem, which I think is implementable. I had actually, so we'd been doing a bunch of Homenet interims, and in one of the Homenet interims early on, we decided we were going to go down the path of coming up with a really clever solution for how to do DNSSEC in a way that hosts that supported it could do, and everybody, it would be kind of, we'd use home.arpa, we'd do signing of home.arpa, and we'd have a way to establish trust. And when I actually wrote down all of the steps that were involved in making this happen, it was clear that it could be made to work, but that it was going to be really hairy and hard to implement and brittle. And so I decided that I wasn't enthusiastic about that. And I think Daniel actually pointed out that we can do, if we just get some kind of global name with a delegation, then we can do DNSSEC, and that's a better solution. And kind of as a result of the work that Stuart and I were doing in DNSSD on the service registration protocol, I realized there's actually a pretty easy way to set up the delegation automatically. And so the current document actually just proposes to do that. So if you wanted to do DNSSEC, you need a global name delegated. The DS record has the public keys of all of the Homenet routers. So that means that any Homenet router can now sign the zone. if there's a master, if there's sorry, a primary, then for a securely delegated zone, it signs with its own key. If there's no stateful primary, then every HNR signs all of the zones it publishes, which every HNR would be publishing the home.arpa domain or the whatever the domain is, and also any link domains that it supports, which are separate zones. In order for this to work, we need a secure delegation for every per-link internal zone. I didn't come up with a way to support DNSSEC for reverse mappings because the interesting reverse mappings are all going to be locally served zones, and that means that you have the same, trust establishment problem that I decided was too hard to solve. I don't think it's that important. If anybody wants to debate that, there's a microphone there, or there's a mailing list, and I'm genuinely curious to hear if anybody thinks this is bad. And so anyway, I think that the current description of how to do DNSSEC on Homenets works, and it would be great if people could look at it. The way the global domain name works is similar to the way DNSSD SRP works. Basically, somebody, and the obvious person to do this would be the ISP, but somebody has to provide a name server that's going to accept a sort of an SRP style update. If you don't know about DNSSD SRP, it has a mode where you can do basically you send an update, the update is signed with its own key, and so it's kind of a first come first served deal where once you've done the update successfully the first time, which you do based on policy rather than based on authentication, any subsequent updates to that domain are secure because you now have a key that you can validate. So you can validate future updates based on the key that you got in the first update. This allows us to either have the ISP set up a service for doing this, which I think is the easiest way. You configure the HNR. If a provider of an HNR wants to do this, they could set up a domain under which registrations for their Homenet routers can be delegated, or the end user can just get a domain and set up a secure delegation on their own and point it at their Homenet router. The delegated names have to be generated automatically because there's no user involvement here. And importantly, in the current document, Homenet routers do not answer queries for the Homenet domain, whatever it is, if they come from out of the Homenet. So we're not actually, even though this is a global DNS name, we're not actually publishing anything to the internet. In the future, we could describe a way of doing that, but we actually have a nice basis for doing that in this document. A nice, we've established all of the things that we need in order to do that. And so anything else can just be an extension. We don't have to do anything differently. This is a solid basis for doing publication in the global DNS if we want to, but we're not doing it in the current doc. So publication of names, one way to do that is with DNSSD discovery proxy. Discovery proxies, for those of you who haven't been to any of my previous talks on this, are proxies that basically sit on the Homenet routers and listen on the local links for MDNS and send MDNS queries, and listen on port 53, UDP port 53 for DNS queries, and translate those into MDNS queries. So you can then, from anywhere on the Homenet, you can query for the availability of services on any link on the Homenet using these proxies. Discovery proxies are, each discovery proxy is authoritative for its own link. That slide bullet doesn't actually make sense. So there's basically several different layers here. One is the per link stuff, which is always done with discovery proxies and is stateless. And then there is a per Homenet domain, home.arpa, or if you've got a delegated domain, it's that domain, whatever it is. And that domain can either be stateful or stateless. If you have sort of really simple Homenet routers that don't have stateful DNS servers in them, then it's just stateless, and you agree using HNCP on what's going to be in the zone, and then every Homenet router publishes its own zone, its own copy of the zone. So you could query any Homenet router and get answers in that zone. and then the stateful DNS resolution is not mandatory to implement, but we specify how to do it and how to make it work. So if there are if you buy a Homenet router that supports stateful DNS, then you can also have several Homenet routers that don't, and it all works in principle. We haven't actually tested this. Let's see. There's now a detailed specification for how link names are generated, which I think will result in link names being generated that have some hope of making sense to the end user. Obviously, there's no guarantee of that, but at least these names will not just be gibberish. They won't just be like, what's the phrase that you use, Stuart? Hexadecimal vomit. Thank you. Not that we're bitter. So anyway, and then there's also, like, a mechanism for doing zone transfers so that all the secondaries, if there are secondaries, remain up to date with the primaries. And that means that if something bad happens and the primary goes away, you elect a new primary, and it's already got hopefully all of the contents of the zone. If there was some last-minute update that got lost, it will be captured when the next renewal happens through service registration protocol. So there's no risk of being continuously out of date or missing data forever as a result of a transition of that sort. Resolution. As I mentioned earlier, the Homenet TLD contains delegations to the perlink subdomains. If the Homenet TLD is stateful, then you have to talk to one of the HNRs that does stateful resolution to resolve names directly under it. If it's stateless, then every HNR answers for the top level domain. So you got these kind of two states that the Homenet can be in, either stateful TLD or stateless TLD, and how the queries are answered depends on which of those you're in. Who manages the perlink delegations is determined using HNCP, and I'll talk about that later. How to do the resolution so that you can have a stub resolver that doesn't recurse is actually a little bit of an open question. Queries for the internet obviously can go just to the ISP's recursive resolver, but queries for the Homenet can't. So either we have to have a recursive resolver, or we have to have something that approximates an recursive resolver, like a discovery broker, which is a document Stuart's working on in the DNSSD working group. So that is actually an open question. I only noticed this issue when I was writing these slides, but I think it's pretty easy to resolve. Having a full service resolver on the Homenet maybe is not great, but there are a number of them that work quite well. I mean, there's I think DNS mask. So it's not out of the question that we could just have a full service resolver on the Homenet, and that might be the easiest way to solve this problem because it doesn't involve inventing anything new. But regardless, we have to have a special DNS proxy because we're not sending all of our queries to the same place. The way that works is that when a host sends a DNS lookup query to port 53 on whichever router they're configured to send it to, that router looks at the domain to see how to resolve it. If it's local, then it has to resolve it locally. If it's non-local, then it just forwards it to the ISP's resolver. It doesn't try to do anything fancy. And so we need to have, as I was mentioning in the previous slide, some kind of way of doing recursion on the local domain. And then for multiple provisioning domains, I think that we can use the PVD option, the PVDRA option that they're working on in int area, which is next. And then I think we need an additional EDNS0 option to specify which PVD we're doing the query in. I looked at a bunch of different ways to solve the which PVD to use problem, and I think this is the cleanest. It's really simple. We have to write a spec for it. There isn't a spec for it yet, but I think it's dead easy. So that's what I propose to do. And I think it was Toko was saying that he is not willing to require that hosts do this, which of course is correct because it's not in the charter that we can require hosts to do things. So if you've got a host that doesn't support the PVD option, then that will be signified by a query coming to the resolver that doesn't have that option in it. And so if the resolver gets a query for something that's not on the Homenet, that is from a host that doesn't support PVDs, then it'll just try, if you're multi-home, it'll try ISP number 1, and then the next time it tries to send a query out, so if that query fails, it will try ISP 2, and then it will try ISP 3, and then it'll try the next resolver from ISP 1, and the next resolver from ISP 2, and the next resolver from ISP 3, so that we get a reasonable likelihood that we'll succeed in getting an answer to the query, and the host will actually be able to connect, and that if the host connects, it will connect to the right thing.
So Ted, I have a question on that. So what's the process of getting an EDNS 0 option?
It's really easy. It used to be hard, but at this point, we need to write a spec, and once we have a draft, we can ask for a code allocation.
Okay, so the code point it's specification.
It's expert review. Well, it's expert review actually. Okay. I think so. Right. It's pretty simple. It used to be like standards action, and that was not so simple, but it's not that anymore. So. And whether to do that in this document or in some other document, I don't know. It seems like it's kind of a general purpose thing, so it probably doesn't belong in this document. So remaining issues, as I said, I think it's mostly complete. We need to write a section that just has like the list of things you have to do to implement a Homenet router, because right now the architecture document just says how the architecture works. It doesn't have any normative language. I didn't want it to have normative language. It just describes how the architecture works. There's a lot of new stuff in here that nobody else is doing right now. We need to test it. And we're in a little bit of a bind here. I've been noticing, so you may have, if you've seen me talk about this before, you may have gotten the sense that I was optimistic about how much work I was going to get done on this over the course of this year. The reality is that I've spent most of my time this year working on DNSSD and issues relating to DNSSD, and have not had time to put much effort into Homenet, other than working on the document. It would be really nice if there were somebody else who were interested in working on this. So if you're sitting in the room and you're thinking to yourself, gosh, this would be nice to have, let's talk. And I can help you with the learning curve on OpenWRT, because I'm a past master of OpenWRT packages at this point. Actually, I shouldn't say I'm a master. I'm a highly skilled dilettante. That's my slides. Any questions?
I want to start with a discussion on why do we have so few people actually reading the draft and just fighting one another to try to implement this. So I'd really like to get some input from people who find the ideas and concepts interesting and useful, but who find that there is something keeping them from taking that next step and participating actively. Do we have anybody like that in the room here? Thank you.
Hello, my name is Jared Mach. I happen to work at Akamai. I find the things that are being done here in Homenet very interesting, because it is kind of designing the technical answer for how you would like to perfectly orchestrate your home network if you have a lot of choice and options and spare time to actually design a home network. I spend my daytime designing networks for my employer, and when it comes to my home network, I keep it simple, because I require my wife and my children to be able to use the network when I am not at home. And adding extra complexity into that is kind of the antithesis of what the consumer, I think, desires. If you look at the successful consumer products, they're ones that tend to remove the complex knobs and features and make it easy to use the technology seamlessly. There's a reason why a lot of people do cloud-centered players and recording for their devices. It's because they don't want to be responsible for maintaining infrastructure in their home to do these things. They're loud. I personally have gotten rid of most of the data center type things for my house because they're loud and they're noisy. And when you talk about doing some of these complex things here, like sending dynamic DNS updates for the devices that, for the CPE for my home, when I don't have any broadband choices and I sit behind double NAT, behind a wireless ISP, these things aren't really applicable to me, for my home network, because I don't have a lot of market choice for these things. Sorry. So this stuff is interesting, but it's also designing the expert solution for the expert people. And I'm not sure about the consumer applicability of many of the things that are going on here. Just to prepare myself for all the tomatoes. I'll sit close now.
Interesting. Okay.
So Michael Richardson, so what I just heard, I don't know your name, sorry.
Jared.
Jared.
Yes.
So hi, I forgot my badge in my room yesterday too. So what I heard is that the document, we're specifying something super complex for super expert people. And so what I heard actually is that our documents are really bad then, because our goal was to specify automated systems for people that don't know anything about what they're doing, specifically his spouse and children, okay, that would operate the network when he's not there. So what I conclude is that we've done something really poorly in our documents there, okay? The other thing is, I'm hoping that eventually he'll get on the internet, because I heard double NAT, and it would be lovely to have an Akamai employee have internet at home. And I'm hoping that maybe you can be among the 4 billion that we're going to hook up soon.
Yes, because there are some telecoms that have fiber within 1,200 feet of my house, but because there's no commercial viability or there's no way to talk to them about it, I actually have to build my own fiber to my own house to span 2 miles to go and get places. And so some of these things are really complex. And when I talk to the wireless ISP, whom I sometimes provide consulting resources for, any of this complexity in the home, he's just like, why do people need all this bandwidth and these resources?
Okay.
And do these things.
So,
and the
Jared,
complexity here is hard.
Can I ask you a question?
Ted, can I just clarify something first? So I actually heard, just to respond to what Michael said, I heard 2 different essential criticisms. One was that we might be designing something that requires an expert in the home, and I personally, I'm not sure that's true. But the other thing I heard that I think maybe is true is that there's too many moving parts, even if they're all automated. And I think that we do have a lot of moving parts.
Yeah, that is a concern that comes up in the slide deck that I added. Right. So Jared, I wanted to ask you. So have you read the document?
No, I have not.
Okay. The reason I ask is because the introduction to the document says exactly what you said.
Yeah, no, I haven't read the document, and I was responding, I think, to more of the general question that Barbara was asking is, why don't we have a lot of people participating in the activities in Homenet? That is what I heard from her, and maybe I heard that incorrectly.
No,
and that's why I came up to the mic.
Yeah, thank you. Yeah, no, the reason I was asking that question is because I felt like your answer a little bit was not talking about. So our job as IETF people is to build things that produce the result that you want, right? And that's what I want to produce, is something that you would feel comfortable putting in your home. I'm not convinced that we can do that for just the reasons you've stated, but that's our goal. So if we can't do that, that's actually useful knowledge.
Yeah, and I think many of the things that Homenet I have heard in the past aspiring to do, of multi-provider and routing topologies within the home, et cetera, I think those are the things that make some of the other products that people try to use in their home not work well, because they don't share the same broadcast domain, because of the assumptions made about when these other people are designing some quote unquote simple consumer device to do things. Mm-hmm. And so the more complex we make it, the more likely we are to break the consumer products that people are expecting to use. Whether or not those products were designed correctly, I think, is a different discussion.
Yeah, it might be worth actually going through my marketing slides, because I think that we're really just talking about the same stuff that I'm talking about in the slides.
I think so.
Okay.
Michael Abramson, yeah. It struck me, this question was good. So when I tried to get budget to do this kind of stuff, my management had a hard time motivating doing this, instead of like customer complaints about bad Wi-Fi and how do we help the customers to fix their Wi-Fi and home network and so on. And how do we help them do that? Yeah, we do that by letting our customer service get more insight into what's going on in the home. So for us, it's been more about how can I get more information out of the home gateway and correlate that with what the customer is telling us that they have a problem with. So that's one of the reasons I have been, not so active in here, is that I've been, limited funds. What do we prioritize? And so it's been more about managing the devices, the device in the home. Then I do think that the basic premise here, as a engineer, I think this is cool stuff. It's just that for the 98% of the population, the use case is kind of hard, and also some of the like Homenet and the routing and so on relies on the kind of devices that we actually don't have in the field. It doesn't have a bunch of routing interface. It has a WAN and a LAN interface, and the LAN interfaces are switched. There seems to be, at least historically, there's been a bit of a mismatch, but what's actually available, what I can buy and that I can build on, and what we have been talking about here, typically. So that's been my reasoning. Reason.
Why don't you go through your, we are now going to have Ted go through the marketing slides so that it can participate in this discussion. The slide can participate.
Slides do not have agency.
Is it a different deck?
It's a different deck.
I mean, I guess just another process angle of that is it's going to be, if the amount of participation is so small, it's going to be hard to realize, say we have IETF consensus for something here. So that's probably something we want to try and get fixed.
Okay, so market resistance to Homenet. So what is our market right now? So basically, now I want to get realistic here. Our market is not, oh, what happened?
I pushed the button, I'm sorry.
You wrecked everything. Yeah. So our market right now is the people who we could actually reasonably expect to act on what we have right now. It's not the people that we imagine might want to buy it later once something is available for them to buy, because there's nothing available for them to buy right now. So I believe that our market are the following people: managers at ISPs, managers at router vendors, early adopters who are willing to run OpenWRT, although even they can't run this, and developers who are doing it because we're developing it. Those are the four people who potentially might act on what we are doing here. So our pitch to friendly people isn't working because we don't have a product. So if somebody tells you, oh, just go download OpenWRT, well, I tried that, doesn't work. It also doesn't work if your network is in any way weird. Like it sort of works if you only have OpenWRT and nothing else, but even then it doesn't work very well. So we really don't have a product to offer even to early adopters right now. So basically, and speaking as a developer, running this stuff on my network is very difficult. And in fact, I'm not doing it right now. So that's kind of a problem, right? If I'm not doing it, how can I expect anybody else to do it? So I'd be curious if there's anybody in this room who is running this on their network. And I actually pulled some people who are doing development, like the Zero WRT people, and they're not using this. So who's Zero WRT? This is like Dave Tate and Jim Geddes.
They're not using this on the network.
They're not using HNCP. They're not using any of the stuff that we're working on here. Dave Tate is not using Babel on his network. So that's kind of bad news. And then, when I think about going to management at a large company and saying to a manager, I think that you should spend money on this, what do I tell them? What is my sales pitch, right? Because if I don't know what to tell them, then it's hopeless, right? I'm not going to go into a meeting with somebody like that and not have an answer to this question. So so let's look at what we've got out here right now. Our competition. We've got Homenet, we wish, which is a routed mesh with lots of services. We've got layer 2 mesh, and there are several vendors out there right now that are selling layer 2 mesh products. We've got wired to access point infrastructure, right? So that's like Ubiquity. So all of the options that we have right now that sort of solve the Homenet problem, solve it using some form of layer 2, not layer 3. None of them have fancy service discovery stuff. Service discovery doesn't necessarily work on them because of multicast issues, but But that's what people are selling, and people are buying these. Like people are going out, if you go out to Amazon, you can find like at least 3 different vendors that are selling mesh solutions to the problem of how you get Wi-Fi to your large home. So naturally at IETF, we prefer a routed mesh of some sort, but how do we talk people into it? So let's talk about like what you get if you get a routed mesh versus if you have some kind of layer 2 network. If you have a routed mesh, you get, whenever the host switches access points, it has to renumber. Any connections it has open have to be restarted. If I have a Wi-Fi call going on, it's probably going to glitch out or even drop. And latency is quite large for this. It could take a fair amount of time for me to go from one access point to another. On the other hand, yeah?
Are the top level bullets reversed here?
No, I'm talking about Homenet. So this is actually kind of crappy. So if you have a Homenet, this is the experience you'll get. Like, so for example, I actually have a wired infrastructure out to my garage. So if I walk out to my garage from inside my house, I'm going to have to switch access points. And when I switch access points, if the application layer isn't taking care of that switch, I'm going to lose my connection. Fortunately, application layers tend to. Yeah.
Yeah. Hi, Jared Mach again. So I have the same scenario that you have. Is that I have about an acre of, a little bit more than an acre of property, and I have consistent APs around everywhere because the performance of the individual devices and the characteristics of the building properties of my house mean that if I go from one side of the house to the other and I don't have dual APs, and if I don't have them on the same SSID, and if my client isn't roaming properly, I will get poor behavior for a Wi-Fi call. Right. So I don't know if anybody here still talks on the phone, or if I'm old school and I'm one of those weird people who hasn't converted entirely to texting. But when I talk on the phone, I tend to walk around as well. And that's part of my get up from my desk and stuff and do exercise. And so some of these properties of Homenet are going to make it unattractive to me. Right. And on your prior slide, you said, the Homenet approach is a routed approach, and that the IETF something prefers that. And I'm not sure what you mean there by the consensus of the IETF, or is it the consensus of the working group?
So that's a good question. I mean, my experience of this as an area director was that I was an area director for a bunch of int area working groups, including Trill. And it was amazing how much shit I got about Trill. Like, just amazing. How many people were like, why haven't you closed them down yet? They're doing layer 2. That's crazy. We don't do layer 2 at the IETF. Layer 2 is bad. So I'm not going to justify that position. I'm just telling you that tends to be the zeitgeist here. Anyway, so host mobility. So on layer 2 networks, as you were saying, Jared, generally speaking, as you wander around your facility where you have all of these wireless devices, your phone, if it's properly implemented, will automatically switch from one to another, and your call will continue without any issues at all. It's possible that there could be some bad things that might happen, but relatively speaking, they're going to be less bad than what you would experience if you were on a Homenet.
That is typically there is no adjustment in spanning tree, just Mac learning. There is no adjustment in spanning tree when you hop between APs. Well,
so when you hop between APs, basically a packet goes out a different interface, and the APs are just noticed. So there is an adjustment. It's just very quick.
Right. So it's a well. No. I have two ubiquity APs at home. I can walk all across half a second interruption or a second. Oh.
Mike.
Oh, okay. So okay. So I fully agree. It's a lot better with flat layer 2 than Homenet. Right. So okay.
Yeah. Michael Richardson. So if you're using spanning tree and you have VoIP and you lose a link, you will likely lose all of your VoIP calls. You can go to RSTP, which is not compatible across vendors. You can go to MSTP, which is sometimes compatible across vendors. Okay. If you add VLANs, then you're screwed. Okay, so there's a whole bunch of things, and actually, just to your point, that's actually one of the reasons why we did Trill, is because all of this was broken, and we needed actual real routing in data centers to make that happen.
Right.
But to the point about walking around in Homenet, so what you're really talking about is the fact that we made a decision that the Wi-Fi would not be bridged for reasons of congestion with the link.
Yes.
And there's lots of companies out there selling you systems that are mostly vertically proprietary that do things to make that all better. Okay. And we haven't specified that, but what the problem is that we haven't told people you have to do that in your Homenet, right? It's just, that's the kind of default that OpenWRT's HNCP comes up with, right? So I think it's important to distinguish what our specs say and what the reference implementations does.
To be clear, what our specs say is that you do routing. There isn't a way using our current specs to not do routing. I mean, I'm not disagreeing that we could solve this problem, but
we just
I
haven't
think you're
solved the
bringing
problem.
up some interesting things.
We haven't solved the problem, and the point is that it's surprising even to us that we have this issue, and I think that's your point.
Yes.
Right.
Right.
So,
we haven't really. Yeah. So basically, I'm just doing a comparison here, and this one happens to be kind of. Julius. Now I'm in trouble.
Go ahead, Julius. We can't hear you. I'm having visions of deja vu all over again. No, we can't hear you.
You mean Meet Echo isn't working?
No, can't hear you.
Yeah, Meet Echo works.
Oh.
I think it's
We can
Try
see you
again.
smile. Can you do sign language?
Nope. Doesn't work.
Nope.
He said on Jabber he would do it in writing, so then I will. If Julius can type up, I can relay. You know.
Okay. Let's do that.
Okie dokie. Jabber away. Huh? Well,
I don't know. It's nice to see Julius.
no.
I'm sure.
Okay, I don't know if we should continue and I say what he said in 2 minutes, or
It's
Yeah.
typed it down.
Let's hear what he said.
Do you have more slides?
Or I
Doug?
mean, if
okay.
I have plenty more slides.
No, I'm Julius. Layer 2 mobility is an interesting issue and one that we have been struggling with for years. And one that probably we've done one that we have been struggling with for years.
Yeah. So I mean, I think that the takeaway that we should have from this is maybe we need to think about whether we're actually solving the right problem here, but also is what I said here actually true? Like, because there are a lot of people who think that doing this on layer 2 works really well until it doesn't, and so you know.
I specifically got 2 Ubiquiti APs that are on the same layer 2, so I can walk from one side of my domicile to the other while doing a VoIP call.
Right.
Running this in Homenet with the current way that HNCP sets up things, it would be a complete no-no. It would be worse than whatever had before.
You would rather have a VLAN on your Homenet than or something.
100% yes.
Or basically, you'd rather have it be bridged somehow.
I would rather have one AP with really bad 2.4 gigahertz covering the entire domicile than these 2 5 gigahertz that give me perfect Wi-Fi everywhere in my domicile. This handover is like a complete no-no. None of the applications or layer 3 handle any kind of handover of anything between there. It's awful.
We could talk about this at length. Do we actually have something new to say?
This would work great if we were using multipath TCP. Multipath, yes, would great.
Right. So basically solve it at the transport layer. Yeah.
Michael Richardson. So I have something new to say. One of the advantages about finding a solution that works at layer 3 is that it makes it much more doable in the future to be able to separate different categories of devices, specifically refrigerators and light bulbs and whatnot, to be able to separate them from other traffic. And when you realize that you're going to have to do that, then it suddenly becomes very useful that you can solve the layer 3 isolation or mobility problem at layer 3, right?
Right. Yeah. I think the one of the best stories for Homenet is actually IoT. Anyway, so I'm going to just talk about some more comparisons. So service discovery, we need a complicated name resolution infrastructure, which we are defining, and I think will work really well. Probably works better than doing service discovery over multicast for a variety of reasons having to do with the way multicast is handled on Wi-Fi networks. But it's complicated. It's got to be done right. If we get it wrong, it won't work. And it won't work in ways that are probably hard to debug. So on a layer 2 network, you just use MDNS, which means using multicast. That's not great, but you can probably make it work. And by the way, there are ways to mitigate the multicast traffic issue, like, for example, just unicasting to every station. I don't know why that's not more common, but it's not, as far as I know.
Dave?
Dave Taylor. Just use DNS is not a statement that can really be applied to home networks. They can be applied to domains for which an administrator controls what application runs.
You're missing what the slide says. It doesn't say just use DNS. It says just use MDNS.
I know what the slide says. I said it incorrectly out loud. Sorry. The point is that in home networks, people run arbitrary applications. Arbitrary applications often use service discovery protocols that they implement themselves, like built into the application. That might be 20, 30 years old or whatever, because the application was written 10 years ago and they're still running that thing. So people that do home LAN play games or whatever else. And so, yeah, whether that's, net bias, whether it's some link local multicast thing that they implement themselves, whatever it is, right? MDNS is fairly new to the game as far as the history of home networks go. And so
it's only 20 years old.
Yeah. And so of layer 2 networks, the bottom slide, as long as everything is on the same subnet and it is broadcast capable, multicast capable for the link, then all the old style stuff works. Okay. On the top half, once they're not on the same link, then all the old style stuff starts breaking. And so some apps work, the ones that might be using, the complicated stuff or the MDNS, the DNS proxies or whatever, and all the ones using legacy protocols stop working. But kids and people that are not us actually notice that things break, and so that causes them problems. And so this should just say, just use MDNS or any other service discovery protocol that exists that uses link scope traffic.
Fair enough. One thing to point out, by the way, is that the multicast partition problem exists on many, many, many home networks because nobody knows how to operate home networks, and so they wind up just plugging routers together using Ethernet cables, and multicast does not work from one router to the other.
Stuart Cheshire, I agree with what Dave said. My reading of that slide was, in that context, MDNS is kind of a placeholder for anything that's using link local, multicast, or broadcast.
Right. But as Dave was saying, the limitation of Homenet is that we just can't support that.
And the points that you make there are applicable to anything that's using lots of multicast and broadcast. It can be expensive on Wi-Fi.
Yep.
Some Wi-Fi access points block it completely. This is common at universities and companies. They just block multicast, so discovery doesn't work. So
yep.
We're kind of stuck between a rock and a hard place, between two things that don't work very well.
Right.
Hi, Steve McCann, Blackberry. Whoops, a bit loud. Completely new to this group, but I thought you might like to know that 82.11 has just finished an amendment, 11AQ, called Service Discovery. And there are some aspects of MDNS, although it's not explicitly called out within that amendment, operating over the Wi-Fi air interface. So some of you guys might want to have a look at it. There may be some interesting things in there.
Are they doing something to deal with the multicast issue?
Yep. Yep.
Okay.
Group addressed. Yeah.
Group addressed.
Yeah, MQ.
802.11 AQ.
802.11 AQ.
Exactly. Yeah.
Thank you.
So Dave there. So since this is the marketing problem, part of the other audience would be the gateway vendors or the vendors of the boxes that span, the things within the HomeNet, right?
Right.
And so if you think about their marketing problem between choosing between which one of these, even if they support both, right, which is the default or whatever, right? They look at this and say, well, if the customer puts something in and his app stopped breaking, what happens? They return it to the store. And so they're driven by things like what's going to actually minimize returns.
Right.
Okay, and so right now the L2 mechanisms are the ones that minimize returns for these reasons. So.
Yeah, although it turns out that we've had some reports of people running into problems with mesh routers failing to do multicast correctly and therefore getting returned. Okay, so let's go on to routing. On Homenet, we have a routing fabric, which maybe works. As I said earlier, I've heard some discouraging reports from Dave Tate. And one thing that's really interesting about having a routing fabric that you don't get if you don't have one is that you can join it with things that are not Wi-Fi routers and get routing instead of bridging. That's kind of nice. It keeps traffic isolated so that your IoT network is isolated from your Wi-Fi network and doesn't see all of the multicast traffic on your Wi-Fi network and doesn't see any other traffic that might leak. So on layer 2 mesh, we have a proprietary or IEEE layer 2 mesh protocol. I think the IEEE layer 2 mesh protocol doesn't actually work, but maybe that's changed over time. I don't know. Last time I looked, yeah, 11S. It was kind of a disastrous failure with OLPC, but that was quite a while ago. So and then on infrastructure or mesh, traffic isolation relies on spanning tree. Spanning tree does not help you with MDNS. It doesn't entirely work for neighbor discovery either, because neighbor discovery packets have to be seen by the whole network in some cases. So doing isolation on a layer 2 infrastructure is not easy. On the other hand, maybe that's not important. But these are the things that I'm just going through the bullet points that you would go through in a marketing presentation. Isolation. We can have separate subnets that are firewalled from each other. We can have a DMZ. We can do service discovery across the DMZ on a home net. You can't do that on layer 2. We can, on layer 2, we could use VLANs for isolation, but then we need routing between the VLANs. We need to be able to do service discovery across the VLANs. So we wind up actually replicating a bunch of the technology that we're inventing here. Standardization, Homenet can in principle be standardized. We're not quite there yet. Hey, and then L2 hub and spoke is pretty straightforward. We already know how to do that. I don't think we need any new standards for that. L2 mesh isn't standardized except for 802.11s, which I don't think works. Maybe I'm wrong. So that's actually like a feature if you're a router vendor, because it means that once you've sold somebody one router, they have to buy all of their routers from you. And if you're a host vendor, you don't care because it just works. Hopefully, if it doesn't work, then the customer probably returns the router. Stateful name service. So Homenet can do this without adding much complexity because we're already supporting stateless name service, which doesn't need to be supported on a flat layer 2. But so if you have a flat layer 2 and you want to do stateful name service or want to do DNSSEC, then you're going to be adding a lot of stuff to your router that you don't currently need. But they could also just say install an appliance or do it in the cloud. So not sure that's actually an important distinction. Code complexity, I think that Homenet kind of loses here. It's not necessarily the case that the layer 2 mesh implementation is less complex than Babel, but they are, the vendors who are selling this already have it, so that doesn't really buy us a whole lot. And we do have a whole bunch of moving parts here that need to work right. And discovery proxy, full service resolvers, Babel, these are all significant piles of code. Whereas like on a layer 2 gateway, all you really need is a dumb DNS proxy. Maybe you need a DHCP server. It's pretty simple. So I think we kind of lose on code complexity. Multi-homing, Homenet does pretty nicely. If you have a layer 2 network, you could probably do it. You're probably going to have multiple RAs per ISP. The host is going to have to figure out how to deal with this. But it's pretty simple to specify. I'm not convinced that we actually win here. I mean, there's a lot of complexity in the way that Homenet works to make this work.
Michael, for the host, it looks the same way. I mean, you get multiple prefixes in RAs when you connect to a Homenet, and if you do it in another way. So for the host, it's no difference, I would say. Well,
the one difference that you might notice is that we perhaps support MPVD stuff better on the Homenet.
Sure.
But yeah. And in fact, I mean, that's, the features that I'm talking about for the resolver are actually offering a service that I think a layer 2 gateway probably would never implement. So What is up with, is there a way to make that title bar go away so we can read? That's really weird.
No, no.
Just click there.
Hit this again? No.
Nope. Oh,
Nope,
there we go.
There we went. Right.
Excellent. All right. So secure services on the HomeNet. If you want to do ACME, you can do that with IPv6. Presuming that you have global IPv6 addresses, you can get an ACME cert anywhere on the HomeNet.
If you have a name. If you have a name.
Well, right. But we can do that, right?
No, that won't work.
What's that? I know. Yeah. So a layer 2 device can also do ACME. It's pretty straightforward. Again, requires a DNS delegation. So in that sense, you'd have to add some features to the HomeNet router. Let's see. So, and why this is important is because it means that you can have a browser that doesn't have a bypass button in it, basically. A browser that doesn't ask you to violate your own security to do something really stupid security-wise, and train you to do that. So I think that's actually a pretty important thing. You know, you can also do secure communication with OEM apps and stuff like that using PKI. So that's I think HomeNet somewhat wins on this, but. Yeah.
So Michael Richardson. So actually, there's a bunch of things that we could talk about in this space, but you know, as Jared shared, we could have, you know, router home, whatever. What was it he said? He said something .router, right? Router.local, right? That would be the good name that you could get, right, and get it into ACME, but it doesn't work. But actually, one of the things that is relevant is that you really do want somehow to be able to get a TLS cert for a name that has a ULA underneath it so that you can talk to your router to reconfigure it when you have lost your connectivity.
Yep. And
your browser has removed all the bypasses, right? Maybe we can make a deal with the browser people, a little bit of quid pro quo, that they finally implement
TLSA?
No, implement link local addressing with the percent blah, 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 which they've refused to do. And then we can, you know, say you can remove the bypass but part of that is though, we need to, and this is a potential real actually work item that we may actually need to push over into, I don't know if it's lamps or something else. It would be really nice if we could have a TLS cert that was bound to.
Which slide was this?
You keep going.
Oh, okay.
Keep
It's
going.
bound
We're
to.
just going to ignore you while you're talking.
It's a bit disconcerting, but okay. That was bound to an Ethernet address. So specifically, if you could get a TLS cert that was bound to a layer 2 address, first of all, it would be boundable, obviously, to a link local address that was derived from it, whether that's a stable, whether it's a randomized MAC or not. But the point is that the vendor would be able to ship it with a certificate validated by the vendor, which says this is really router number A:23:478, right? That would be really useful because that would get rid of this problem. And I really think we need to somehow have this. And if we don't do that, we don't have some mechanism, then somehow some browser is going to always have to have that exception so that you can talk to things in the beginning. And it's a real problem, okay? We did something in our secure home gateway work that I can talk about later that, you know, might work for us, but it might not be generalized with the other manufacturers, but it's kind of a nice hack anyway that made it work. So
Okay.
I agree it's a potential win.
You have 2 more slides. Okay, Jared, go ahead. But quickly.
Hi, Jared. I'm not going to ask my wife to type in FE80::, and a bunch of percents and then figure out what the local interface name is.
That was my problem with that too.
That's not going to work. And I think that if you see the way this is currently being solved for the consumers, if you buy certain routers, they have a, you know, my router login dot whatever, and when they set themselves up to be the DHCP server, or DNS server, they just answer for all the clients, and they give the correct answer for them, for the service level answer for their device with an actual domain name. That's how you actually see this play out. And the TLS cert support. And you don't need a TLS cert because you're probably plugged in via physical Ethernet, or you're using the Wi-Fi password that is on the sticker on the underneath of the device.
I think that we're going to have a religious discussion if we try to continue this, so let's not.
Okay.
Yes.
Let's finish up with your slides.
Stuart's going to get me.
I'll be very brief, but I want to answer this because it's something that I've witnessed changing over the last decade. As browsers have become more strict, this is becoming almost unusable. I've got a bunch of stuff on my home network that has embedded web servers. Much of that has moved to HTTPS, which on the face of it is a good thing because it's more secure. The inverters for my solar panels, when I connect to them, Safari says, this is a bogus certificate. I can't trust this certificate. And then it needs my admin password to override the security, which is very discouraging for an end user. There's a very clear message that you do not want to do this. This is a bad idea. And I know Firefox did some experimental work on how you have TLS certificates for things that don't have globally unique DNS names. I don't think it ever shipped in the main version, but this is a very real problem.
Yep.
Okay, I'm going to ask Ted to finish up.
Yes, so IoT support. This is actually, to me, kind of the killer app for Homenet because you can have your IoT edge routers, which is to say the outside edge of the IoT pointing at the Homenet, join the routing fabric of the Homenet. And you can use stateful service discovery on the Homenet and everything just kind of works. So this is actually a pretty sweet thing. With layer 2, there are ways to make this work, but they're all kind of kludgy and they require the host to do things that are of questionable safety. And getting transit between IoT networks can be challenging. And it actually, when I was writing this, I was thinking, you know, if I were an IoT edge router provider, I would want to implement Homenet in my IoT router so that even if the main router on the link doesn't implement Homenet, my two IoT routers can have a routing mesh between them. So interesting. So what am I missing? I think the strongest pitch here is IoT. Problem is that unfortunately, the people who are most likely to make routers are not making them for the IoT space, and so they're not going to care about that pitch. Personally, I think having Homenet services would be much better than having a layer 2 network in many ways if we could solve the roaming problem, which I think is a real problem. So the problem that I have with this slide deck, the reason I composed this slide deck is because I actually don't know, based on what I just said to you, what my pitch would be if I went to, you know, a VP of a router vendor company to try to pitch them on implementing Homenet. I don't know what I'd tell them. I don't have a clear message that I think would be convincing. I don't feel confident. I don't have belief in this message. And so even though I personally, as a hobbyist, think Homenet is great and might be willing to continue working out on that basis, that's not going to get us over the finish line. If we really think Homenet is worth doing, we need to answer these questions. We need to seriously think about this and not just be like, oh, I'll come to Homenet because it's kind of interesting. Right.
This has been really helpful, Ted. I really appreciate your putting this together and challenging us on these questions. I'm thinking we need to really take this to the list. Mm-hmm. I'm kind of wondering if you could drop the content of these slides just into a draft, yeah, and submit it so that we have something right to throw things at other than you, but kind of something, you know, like a draft that it'll hurt less.
Right.
Hi, get with me afterwards. I'll volunteer to help you with this.
Cool, thank you.
Cool. And what I would like to see is this might cause us to rethink the architecture, reopen that, and it would also feed into any rechartering discussions that we might have. So now we don't have to do that anymore.
That's good because we spent a lot of time on this. Do we have time to go over the HNCP stuff, or are we burned?
I could give you about 5 minutes.
All right.
But first I want to just go back to the simple naming. I've got some more. I've sent one email on simple naming. I'm going to be sending some more. I'd suggest that anyone else who has comments, and some of them do get to some of the things you brought up in your slides. So I think we'll have some of that discussion on the list as well.
Great.
You said you had some comments too?
I do. So I guess, but in response to this, I mean, one of the other possible outcomes is, shit, we just can't do it and we should stop. So I think we need to convince ourselves that that's not the right outcome as well.
Yeah.
Right?
Yeah. Well, and another outcome is we could say, look, this is really cool stuff, but actually it turns out that having a flat layer 2 routing infrastructure is a hell of a lot easier and more likely to ship than having Babel and all of that stuff. But you know what? We're also doing some really interesting stuff on service discovery and naming. So let's just do that.
Sure. I mean, I guess we could point to Terry there and say this.
We are doing interesting stuff.
Yeah.
Is interesting stuff
on naming?
Well, no, I think interesting and useful.
Naming, I think what we heard was that we have some applicability around naming and around especially securing the namespace, because if we can't get the browser guys to do anything, then we need to be able to pass their browser checks and things. But go ahead, Terry.
So I'm going to echo what a few people have said already. This has been a fantastic discussion. I really appreciate the very collegiate way everyone has come to the microphone. Good on you. Yes, there's some interesting stuff here. What I really want to call out is that RFC 3935 or something like that says the IETF's goal, its mission, is to make the internet work better. What Ted has identified here is situations that it doesn't make the internet work better. In fact, the exact opposite. So I'm really keen to see effort put in to this to either address those issues or, as Stephen mentioned, go, you know what, maybe we can't. I'd hate to think that's the outcome. And I think Stephen's right that we need to put in a lot of effort, not to convince ourselves, but to have the answers as to how we make it better. So yes, I think there's interesting work here, and I'm going to let it go. It has to keep going for those reasons. I really do dislike unanswered states, and people throw their hands up and go, it's all too hard. That said, I'm also taking on board some of the aspects with this of it takes effort. It takes a lot of effort. It takes people to be invested. It takes time, and it takes money. And so I'm going to be watching that as well. Please continue.
Thanks.
Thank you. Okay, so you've got like 5 minutes to do.
Okay, somebody needs to give me my slides.
You're so demanding.
I know, I'm a pain. I apologize. Terrible.
Let's see, it was the HNCP update.
Yes.
Okay.
All right.
Let's see.
Full screen. More full screen. Click it again. Yeah. Okay. All right. Yes. Okay. So new HNCP work. This is the overview. Publishing. We need to be able to publish keys. Homenet routers need to have public keys and private keys. We need to be able to name links. We need to be able to elect Homenet routers to do service discovery for each link. So there might be more than one Homenet router. We need to be able to maintain a list of stateful authoritative services, which may be empty. We need to be able to elect a stateful primary. And we need to fix the IPv4 addressing fail, and I will now explain what those are in less than 5 minutes. So each Homenet router needs to generate its own public-private key pair. It can publish the public key using HNCP. Now every HNR knows every other HNR's public key. We can use this for mutual authentication. This does not help us to establish trust, but if we find a way to establish trust, we can use it for mutual authentication, and we can use it for DNSX signing and validation. Link naming, we need to be able to come up with names for links, and links may be connected to multiple HNRs. If the link name is somewhat dependent on the name of the HNR, then the link name might change if an HNR goes away. And if you read the Homenet naming architecture, which 2 of you have done, or 3 maybe, then you'll know how that all works and understand why this is important. Per link discovery proxy. So as I was saying earlier, every link has potentially one or more, at least one, but possibly more HNRs connected to it. Only one HNR can be authoritative for service discovery on the link. So we need to be able to elect which one that is. List of stateful servers, just maintain the list. Pretty straightforward. Basically any HNR that's willing to do stateful says, hi, I'm willing to do stateful. We might want to be able to say, I'm willing to do stateful, but I prefer not to. So there might be that slight additional amount of complexity. And then election of the DNS primary, you know, it is the time of the gathering. There can be only one. Homenet routers can come and go. So if the primary goes, then we need to elect a new primary. If some new router shows up, then we need to join it in. The failure mode, the worst failure mode is if there are two HNRs, one of which hasn't yet been configured, and it comes onto the network just as the primary goes away, and now you have lost all of your state. But we need to figure that out. I think we don't really need to solve that problem because I think it's unlikely, but and if it happens, we heal. So, but we need to do that. And then the IPv4 address fail, which is that right now, if you have IPv4 addressing, your internal network will be numbered and have routing for IPv4. And then if your upstream provider IPv4 address expires, IPv4 addressing will just die. And this is very surprising, I know, because I've had it happen to me. If service discovery and IPv6 routing were working, maybe that would be okay, but in my case that was not because I was developing on it. So we need to decide whether this is important, how to address it, and then we need to address it. At the very least, I think that we need to do something other than say immediately when you lose your uplink, all of your downlink IPv4 addressing goes away. It should at least be, there should at least be a delay. But anyway, that's it. Oh, implementations. This is a kind of a problem. As far as I know, there's nobody who both groks an existing HNCP implementation and has time to work on it. That includes me. We need to either get one or more of those people to spend time on it, or we need to put some effort into making an existing HNCP implementation more grokkable. There are, I think, 3 of them out there. Maybe one of them is grokkable. I'm not that fond of them. So, or we need a new one that's more grokkable, that's a little bit better architected. I think, you know, it might be taken personally that I say this, but the existing implementations are kind of piles, and there isn't a lot of layer separation. And so it's very difficult to understand. It's very difficult to modify. And so it might be worth doing something that's a little bit more general. So that's it, I think.
I think you need a reference to Heinlein's Stranger in a Strange Land for grok for people who don't know that term. Just a terminology thing here, huh?
It's in the dictionary. I'm not kidding. It is in the dictionary.
That's really scary.
It's awesome.
Okay. Thank you. We don't really have time to discuss this. Since Ted, you're sitting down, how do you want to pursue discussion of the points you have raised?
Well, I think we need to have discussion on the mailing list. If people, I mean, you know, we keep seeing rooms with like actually kind of a nice number of people in them. And I don't know whether everybody's just in here because it's a convenient place to read mail, or whether it's sort of like watching a train wreck in slow motion, or whether people are actually interested. But if the answer is that they're actually interested, then even a little bit of engagement would be better than the amount of engagement we have right now.
Okay, then I'm going to start by sending an email to the list with a pointer to the slide deck and ask people to start commenting from there. Okay, Michael, that's scary. I don't know that I can unsee that.
Yeah, unfortunately, the video is not mine and it's unpublished, so you have to know the link. So thank you for typing that in. So my name is Michael Richardson. While you're doing this, I've worked since about May. Just hit pause first. If you can do that. That's a good spot there, yeah. I've been working since May with Sierra Labs. Jack Latour, I think, talked to you in July when I didn't come to the meeting, surprisingly. Basically what we've been working on is, we call it the Secure Home Gateway. And a couple of the goals are, one of them is that every device comes with a name, and CIRA is the Canadian Internet Registration Authority, so .ca. And they obviously have an interest in more people having .ca names. So the concept is that every device would, home router would come with a name, and you'd retrieve it by a voucher, and some of the advanced home net naming stuff that we have talked about would apply directly. But one of the other sides of this, and the motivation for it, is essentially that the CCTLDs, having seen the Mirai and other attacks, are terribly terribly worried about weaponizing of IoT devices that attack critical infrastructure. And so the concept is that they would like to basically spend some effort and resources to try to mitigate this at the source. So what we built was, in fact, I don't know what's going on you guys are doing, but anyway.
Just keep talking. Keep talking.
Yeah, keep talking. It's very, very interesting, all these things popping up, and it's like
do you just want to?
yeah, there's audio here, but if the audio doesn't work, then I'll just explain it as we go. Anyway, so the point is that we're building a secure home gateway. It processes MUD files. You could have heard about that in a couple other working groups. And the general effect is that it basically restricts devices that that you can describe, that are specific purpose devices rather than general computing laptops or whatever, to doing just what they need to do. Okay. So this was actually presented at RIPE and ICANN in the last couple of weeks. And we were going to do a demo on site, and we realized that was impractical because RIPE wouldn't let us have a wired drop. And so we did a video, and we actually had built this little box that, you know, I think it was a 3-hour effort to basically push one button and it runs normally. You push the other button and it apparently attacks something, right? And then we could show it. And that didn't work, so we wound up actually going to the kitchen and fetching a toaster. And you could put play now, or you saw that on the screen a moment ago.
We'll be there.
We'll be there, yeah, we'll be there. So we use a toaster, and we called it an intelligent toaster because we taped an iPad to it. But the general model is that the new device shows up on the network, and what happens is that it initially gets no connectivity, and then you have to scan a MUD file, and then it gets connectivity. And Jacques is maybe going to explain it. There, he's explaining that we have this device, and
all of the internet is connected. So we have access to, let's say, here, Suro.ca's website. And also, they would have access to all of the malware website on the internet. So obviously, this is a behavior that we want to stop, is having this IoT device accessing malware site to download malware.
Obviously not real malware, just pictures of malware.
So most of the projects that we have are on Zero Lab, GitHub project. So we got the MUD gateway, we have the slides, we have around 20 different projects to make this. So it's all open source. All
And MUD gateway also runs Brewski, just cause. So it's booting twice the speed, and that's a Tourist Omnia device. We have some challenges and interesting things with whether we run 1806 or their version, and we're running kind of both in kind of a bastardized hybrid that is not sustainable.
All right, so in this device here, we have the Sierra app already pre-configured with certificate that can talk with the router. And this, of course, you could have running in your cell phone or any other device that you want to have the ability to do this configuration. So I'm just going to launch our Sierra app here, and then we have the option to just view devices. And then this is already talking to the router. And we have a list of the devices that's already online. We're just going to select our toaster here.
We're going to pause to try and do better audio.
Doesn't just automatically switch?
Who the hell knows?
Mine always switches. Built-in display port.
Headphones.
Yeah, that's what you want.
Okay.
But maybe not 100%.
Well, it would have just switched if it was.
It played because they're going to control it on the mixer.
That's using the MAC address, the version of the firmware, some of the information here, and then we of course have the option to apply.
We can hear it somewhere. I hear it in the background. Back there. Anyway.
So we're going to click Add MUD file, and what that gives us.
We just need more in the room.
A camera for the QR code. I'm going to scan it. I'm going to hit it again because it's too slow. All right, so it's telling us that this is a valid QR code, and the information that it has is essentially a URL for the MUD file. So it's going to download the mud file, and I'm gonna hit add device. It says applying mud profile. So it just finished. What it did here is that essentially it downloaded the mud file. It applied all the rules in our firewall, and now the device is secure, and it access only the it has only traffic that it can actually access, and everything else should be blocked and secure.
And we've described the app as Tinder for IoT devices.
Now being set up on the home network, and it should have access to the serial network. That should work.
Yeah, actually, Jock wants swipe right, except swipe left, disconnect, swipe up for your PC.
That works. Now all the different malware sites. This had access before, so if we go back to these malware sites, the access should be blocked.
And it fails to load. You can hit stop now. It's done. Part of the interesting thing for Homenet, aside from the fact that to deploy this on things, we're basically going to be using OpenWRT and upstreaming into that, and all of the things HNCP that we might like to work. Well, we have to kind of figure out. We have to actually make that stuff work if we want it to be workable across Homenet type networks. There's no direct dependency. Just it's likely that we're going to do some work on that in that space. Right now, we have to build our ACLs based upon MAC addresses because the network is flat, and it would be we would much prefer to be able to do things among different networks that Homenet would let us have. And in particular, we have no ability to isolate devices that are not hairpinned through the router. So if you plug in a switch, which many of us might do, and then plug in some wired devices, well, of course, we can't isolate those wired devices because it's not a switch that we can manage directly. So it would be better if that was a Homenet router that just was in pass-through mode, because then it could do that, right? So if you needed a 4-port or 8-port router somewhere and you just got one and it happened to be a Homenet router, that would be better because now it would be smart and we would have HNCP and we could actually do things among different things. So that would actually be a feature if all switches that people bought at home were in fact routers. And that's what I predicted several years ago, and it hasn't happened yet, but I'm still hopeful. You had a question, Dave?
Dave Thaler, cool demo. Thank you for doing this. I think I had a couple questions, but I think that they might have been answered. So let me verify that I have the right answer. The first question I was going to ask is, where does it get the mud file from? And the answer was, it's encoded in that QR code, right? And so, because that was when we finally got the audio working, that's what was being explained,
Yep.
right? I scanned that, that's the URI to go and grab the mud file.
Right.
Second question is, what do you do with devices that don't have a mud file or a QR code? And my guess is, your answer is, you don't do any filtering, right? You just let them do anything they want. Is that correct?
The answer is that if you have a device for which you want to do anything it wants, then that would be essentially swipe up, okay? And that might be because you don't have a mud file, or you haven't found a mud file, or you haven't built one yet, or because it would be inappropriate for your laptop to be restricted in where it went. But that's the discussion we're having. So we're actually considering, for instance, things like looking at the first 3 bytes of the MAC address and having a database that may actually return interesting or useful things. We strongly believe that we need to have some kind of a curated crowdsourced database of this. It could be as simple as a GitHub that accepts pull requests and does some thinking before it accepts them. It could be much more complicated, like Stack Exchange or something like this. But we think that people are going to be able to do this. And so that QR code doesn't have to come from the packaging. It could come from a screen, right? Or in this case, maybe you don't need a screen. It just goes directly from one app to the other. But the point is that that could come from a variety of sources, and it could become the public. And the other part of it is that we realize even if the manufacturer provides a MUD file, we may disagree with them, right? No, your toaster can't talk to Facebook. It's not appropriate, right?
The other question I was going to ask, which I think was answered, was what work, if any, does Homenet need to do? And I think you'd said that right now all of your ACLs and stuff is based on the MAC address, which may be gotten from the QR code or something too. I don't know. And maybe there's something for Homenet to do there. That was what I took away. And then let me know if that's not correct. But then the last question.
Yeah, go ahead.
Is the app that you're showing? I couldn't tell. Is that the app that's used to onboard the thing onto the Wi-Fi network, or is that something else?
No.
And if it's not the same thing, why is it not the same thing?
So given that it's a toaster that we made up, it doesn't have an onboarding app. So this is an app that we created. It would be very
in your marketing pitch, would it be?
Yeah, sorry, that's the marketing. So in the ideal situation, it would be the same app that was used to onboard the device, assuming that devices could somehow deal with some standard. We are looking at the question of how do we onboard the router itself, given that it has no internet when we onboard it. I had only 3 minutes at Anima to talk about that document, but my slides are in the archives, and I would love your feedback. And it's related to, but not identical to DPP, because DPP is not deployable on current iOS or Android devices. There are no APIs to send the packets that we like. And so I would like to do something like it over link local IPv6 on unencrypted Wi-Fi. But, I don't always get my way.
Okay, thank you. I really appreciate it, Michael. And I would like to now, Mikhail, which I know you sometimes call yourself Michael, but that would just be too confusing. So he hasn't any other business topic to briefly introduce.
Yes, Michael Abrahamson. So I installed, okay. So there has been some talk about different, not getting IPv6 and so on. I'm in the fortunate situation. I have one DOCSIS connection and one fiber to the home connection. They're both dual stacked. I both get /56s through them. So I thought, okay, I'm going to try a Homenet. So I took OpenWRT 1806.1. I tried to install the Homenet suite of packages. I got some conflicts. I had to remove the existing DHCP v6 server, then Homenet installed correctly. I had to fight a little bit with the configuration and losing connectivity and having to muck around, but after a while I got it working, and I had 2 uplinks and get both prefixes, and it was announced on my LAN and so on. I took another one. I did the same thing, hooked it up to that first one, and Babel seemed to kick around. Everything was working, and it didn't do double NAT, but single NAT out on the external interface and so on. That seemed to work. Then I noticed that I had 1 week of lease time from one ISP and 12 hours from the other one, and the 12-hour one was the one I really wanted to use as a primary. So all my hosts chose the 7-day one, of course, because of the lifetime of the prefix. So that's one thing we should do. We should put in the ability to cap the lifetime you get from an ISP to be able to influence what the hosts choose as their primary upstream.
Did you see the conversation that's been going on in V6 Ops on exactly this question, where Mark Andrews is suggesting we need to go the other way? That we need to make it mandatory that things abide by the lifetime. Anyway.
No. I'm saying in eight.
Yeah, you're saying lower the lifetime, but yeah.
Yeah, that's what I'm saying. I want to control. I want to be able to cap the lifetime per provider, per upstream. To say, if you get 7 days here, no, I want it to be 11 hours, and that's what I want you to use in HNCP and for the RAs and stuff.
Do you want to be able to cap the lifetime, or do you want the Homenet router to automatically notice that the lifetimes are different and even them out?
Well, evening them out doesn't help me. I want
you actually want to be able to say which ISP you prefer to use.
Yes.
Okay.
So when my hosts are modified and they are smarter and they run MPTCP and so on, they will use both. So, but I want to be able to influence this.
Right. Okay.
Because right now with my unmodified host, they just went 100% to the one I didn't want to use, which was not desirable. So either by default, taking the lowest value and saying this is both. And then another thing is the way I had set it up, I wouldn't get a link down event. So there is some other work on detecting. I think we're proposing that in V6 Up to check the liveliness of the upstream, because here in this case, we actually want to fail over to the second one, because for me, this was now more of a redundancy case. I wanted to be able to, if one went down, I wanted to use the other one. So that doesn't work currently either. But apart from that, the code seems to, I ran this for a couple of hours before I said, okay, I don't want to use this for my live network at home. The same wife, observation that Jared had. So, but from that part, it still seems to work in 18.06.01. The code seems to be. I don't know how much is being maintained. Marcus said on the Jabber chat that he's still maintaining it, but it seems to work in 18.06.1 so far.
Cool. Thank you. And yes, I have the same spousal unit issues that both of you discuss. And okay, that's it. You got anything to say, Stephen?
Well, where's the blue sheets? And I guess the main thing we should try and discuss this, what Ted called a marketing problem, but maybe is an issue of what to address on the list. So talk to you on the list. Thank you.
Thank you, everyone, for the lovely discussion. Oh, make it stop. Okay.
Is there somewhere? I gave it to somebody. Thank you.